So today I'll be teaching K-maps, also known as Karnaugh maps. And these are very similar to the Quinn-McCluskey method. So at the end of today, I'll be going over two questions, one of them being this right here. So it's going to be represented in SOP form. So what is SOP? SOP is basically you have terms. Let me just write some terms out. And like this. So what it is basically is sum, right? The sum denoted by the plus sign of products, which are these terms. And it should be in this exact form. So the other form is POS, which we won't be covering this lesson. Is we have terms in a bracket that are added to each other. So basically A plus B, and then it's multiplied by another bracket, which can have any other form. And then it keeps going. Now we have an example of a K-map, which is similar to a truth table, which is basically this. Actually, let me do A, B, not A, not B, and this is 0, this is 1, this is 1, this is 0. Something like this. I should probably leave that. Now, before I get onto this grid, we should talk about the actual usage of a K-map. So a K-map is used to simplify Boolean expressions. And instead of explaining it, I'll go through the examples and show you how it simplifies the Boolean expressions. So before we move on to the actual example, we have to see a few rules and prerequisites for creating the map. So when we want to group these zeros and ones in this map, right, we have to go through stages. So first we have to find the ones. Well, in this particular question, we start by grouping all the ones. So what is a rule for that? A rule is that the group has to be sizes of 2 to the power of n. So you have this set of 2 to the power of n, which is 1, 2, 4, 8, 16, and so on. So group sizes must be of this size only. So you cannot group the ones like this because there are 3, and 3 is not to the power of n. So looking at this graph, what can we do? Well, I can see a group of 6, but 6 is not in this set. So I cannot do that. What I can do, however, when you have groups like this, it can overlap, right? And when groups overlap, you must overlap it where you can include the most ones as possible. So you have to find the largest groupings as possible, but also the minimum numbers of largest groups to cover all of it. So if we're covering all ones, that's DNF. If it's all zeros, that's CNF. So if it's all ones, it's disjunctive, whatever the word is. CNF is conjunctive, disjunction is DNF. Okay, that was it. So what is the groups that I can make this group into that can also satisfy having 2 to the power of group sizes? We can do that by grouping twice these two groups, right? 2 groups of 4, which is possible because 4 is in the set, which is perfectly legible. Now we have another overlapping group, which you can do is this one. It can go horizontal and it overlaps these 2 groups, and that is also a sample. This is also size of 4, that's what I meant to say, which is okay. Now, can I have, let me choose a different color. Can I have a single group of 1? The answer is, as you can see in the set, 1 is in the set, so yes, we can have a single set. Now, what do we do about these 2? You might think that's just two groups of one, right? Of just one. But you can actually group this together. This becomes an adjacent pair because they're adjacent to each other. So that counts as a group of two, which is also in here. So that's how you would group ones in this grid. Now, let's do this example. Let me put it up on the top here and move this to the left. So before we tackle the question, we should do the example first. So what do we do with this? We should convert this into another rectangular map. Just another way of saying, grouping the two variables. So we ignore the output for now, and we use these three variables. Okay, so this will be let me get rid of this arrow. And then there will be an arrow here to separate the variables. So B and C is horizontal, A is vertical. Let me add some rows. Actually, let's not. So, vertically speaking, with only A, there can only be two outputs, 0 or 1. So that's pretty simple. However, with B and C, there will be two variables, and then we can only have two each, so that's 2 to the power of 2, which is 4. So there will be 4 columns of, 4 columns. I was going to say rows. So the first row would be 0, 0, 0, which is 0. Then 0, 0, 1, which is 1, so we put 1. 0, 1, 0, which is 0. So 0, 1, 0, this 0 here. 0, 1, 1 is 1. So it will be 0, 1, 1, 0. And now, now we have 1. 0, 0 is 0. 1, 0, 1 is 0. 1, 0, 1, 0. 1, 1, 0 is 1. 1, 1, 0 is 1 here. 1, 1, 1 is 1. So we have this as a result. Next, we have to do the grouping. So with all the rules that I have mentioned so far, let's group this table together. So let's create a copy like this. And now let's use a different color to group the ones and zeros. So what can we do here? So knowing that we can only have a group size of 2 to the power of n, we can group this together. And we can overlap here, the other direction. And we can find a final group here. So we have 3 groups. So let's talk about the red group, right? 1 and 1. So 1 and 1 is basically saying 01, 1, 1. And that's when A is 0. So this is B and C, this is B and C. So what does this mean? 0 and 1 and 1, 1. These are the most important bits. This means that regardless of B, C is the same, right? C is the same. Therefore, we can eliminate C. Oh, yeah, we can eliminate B. But Rania is putting me off. Okay, yes, we can eliminate B because C is always the same. So this gives us 1. So after this, if A is 0 and C equals 1, to make this 1, we need not A and C, which is also written as not A times C, right? This is the same thing. A equals 0, C equals 1. To make this 1, we need not A and C. Let me use a different ink. This is all the same. This is just all saying the same thing. Okay, now let's look at the different groups. So we have the red group, now we have the pink group. The pink group is, let me do BC, 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 just so it's easier to look at. Now, we do not talk about the pink group, we just talk about the red and blue groups, right? These two groups, because they cover all the ones. The pink just covers just two of the overlapping ones, so we don't need to count pink, but we just group them. So for the blue group, we can say when A equals 1, BC equals 1 1 and 1 0. Oops. Like this. What does this mean? This means regardless of C, I really can't write. So you can see here C is different, right? C equals 1, C equals 0. However, B is always 1. Therefore, we can eliminate C. Or we can eliminate B. Oh no, C. Because we don't need to change C to make this true. B is always 1. So, A equals 1, B equals 1. How do we make this 1? We can make this 1 by doing A and B, which is literally the same, literally the same as what this is saying. Or A and B. Same thing. So, with these in mind, let's write them out again. This form. We'll use the DNF form. So minimized DNF form is AC plus AB. And that's our answer. We just have these two values and we plus them together because that is the rule of the disjunctive form.